Example 9. Find the number of permutations of the letter of the word Allahabad. Okay. So in this question, we are going to apply this theorem. The number of arrangement of repeated object is given by n factorial upon p1 factorial into p2 factorial and so on up to pk factorial, where p1 is the number of times the object of one kind is repeated, p2 is the number of times the object of second type is repeated, pk is representing the number of times the object of kth kind is repeated. Okay, so first of all I take these letters and separate them. So A, L, L, A, H, A, B, A, D. Okay, so this A is going to come here. So first of all, these letters are 4, 2 and 3. That is equal to 9 letters. So in all, the total number of letters are 9. Okay. So n is equal to 9. So the total number of permutation obtained would be equal to 9 factorial upon. Since A is repeating 4 times, so we are going to divide it by 4 factorial, and L is repeated 2 times, so we are going to divide it by 2 factorial. Okay. This will be equal to 9 into 8 into 7 into 6 into 5 into 4 factorial. So this 4 factorial cancel out into 2. So this 4 and 4 cancels out. Okay. This is going to become 3. So the total number of arrangement would be equal to 9 into 8 into 7 into 3 into 5. Okay. Okay, and on multiplication I am going to obtain 7,560 words. So number of permutations would be equal to 7,560. Okay. In example number 10, we have been given how many 4-digit numbers can be formed using the digits 1 to 9 if repetition of digit is not allowed. Okay. So total digits from 1 to 9 is 9 and we have to form a 4-digit number. So the number of ways of arranging R objects from the total of n objects is given by NPR. So we have total 9 digits and we have to form a 4-digit number. So total number of numbers which would be formed would be equal to 9p4. Okay, and this will be equal to 9 factorial upon 9 minus 4 factorial. Okay. Okay, by using this formula, n factorial upon n minus r factorial. So this will be equal to 9 factorial upon 5 factorial. So this will be equal to this will be equal to 9 into 8 into 7 into 6 into 5 factorial upon 5 factorial. This and this cancels out. Okay, which on multiplication gives me 3024 ways, 3024 numbers. So 3024 numbers which are 4 digits are possible. Okay. Question number 11. How many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5 if the repetition of the digit is not allowed? Okay. So first of all, we have to form the numbers between 100 and 1000. And we have been given the digits 0, 1, 2, 3, 4, 5. So this means that the numbers which we are going to form with these digits, and they are 3-digit numbers, so 100 won't be there because 0 is only taken once. So the numbers which we are going to obtain, all the 3 digits number will be between 100 and 1000. Okay, so one thing is cleared. Now let us assume that we form 3-digit numbers with these 6 digits. Okay, then the number of way of doing so will be equal to how much? 6p3. Okay, so if we are going to arrange these 6 digits in these 3 places, then we are going to get the total number of combination of 3 digits, that is 3-digit numbers. And this will be equal to how much? This will be equal to 6 factorial upon 3 factorial, and on solving I am going to get this as 120. Okay, but in doing so we got those numbers also which had 0 in the 100th place. Okay, so in these 3-digit numbers, in these 120 numbers which were 3-digit numbers, we also got the numbers which are 2-digit. Okay, so we have to now subtract those numbers which are 2 digits from this 120 which were formed in this process. Okay, so the total number of 3-digit numbers, or the total numbers having zeros at the 100th place, would be equal to the total number of ways in filling these 2 places with these 5 digits: 1, 2, 3, 4, 5, and this will be equal to how much? 5p2. Okay, so this place is always going to be filled with 0, so these 2 places are to be filled, and this will be equal to 5 factorial upon 3 factorial, so this will be equal to how much? 20. So the total number of ways, or the total number of 2-digit numbers, would be equal to 120 minus 20, that will be equal to 100. Okay,